In 2.7, we're going to be looking at complex numbers and different things that we can do with those. In previous sections, we did kind of allude to it once, but today we're going to go quite a bit more in depth. So the first thing I want to do is just kind of do a slight introduction and show you why we need this and where it kind of came about. So say we need to solve the following problem. As we know how to do, we would subtract 4 from both sides, giving us x squared equal to negative 4. Square root both sides, giving us x equal to plus or minus. You run to your calculator, and this will not go into your calculator. We know the square root of 4 is 2, but now the fact that there is a little negative under here, this is where we pick up this concept of I. Basically giving us a way to finish out in solving our problems even with faced with a negative under our square root. So the correct answer for this would be plus or minus 2i. But let's go a little bit more in depth at these imaginary units, how we can use them, and how we could possibly do operations on these different i's. So we get the imaginary unit I. It's normally a lowercase I. Typically you kind of see it italicized or in cursive here. I represents the square root of negative 1. If I were to square both sides, that would give me I squared. Square of a radical, the square and the square root cancel, just give me negative 1. So I also pick up that I squared is equal to negative 1. We're going to use both of these in a couple of different situations. So just kind of some basics. How do I work with the square root of these negatives? Say I had the square root of negative 25. That means it would be 25 times negative 1. Rules of radicals, I could break this apart and just look at the square root of 25 times the square root of negative 1. We know the square root of 25 is positive 5, and by the above, we can see that the square root of negative 1 is just I. So we're able to take negative square root of 25 and get 5i. And you'll have some of those problems on your homework as well, where you just need to break down the negative radical and get your imaginary unit. Now, all of this imaginary number can be said, we can get things known as a complex number. A complex number is a number of the form a plus bi, where a is your real part and the bi is your imaginary part. This is standard form for a complex number to have your real part plus your imaginary part. So you're going to see that quite a bit, where in your answers it'll say write in standard form. And that just goes on and it says, you know, if b is equal to 0, then you just have real, and if a is equal to 0, then you just have the imaginary part. So a couple of examples that you can see with this and what you're going to see in your homework. It says express the square root of negative 9 in standard form. Notice it doesn't even say complex number. It has no mention of i's going on in it, but we know that we could square root this and we could say, you know, this is the same thing as the square root of 9 times negative 1. The square root of 9 is 3. The square root of negative 1 is I. So standard form would just be 3i. Now I did kind of part that out as we went, and earlier we saw up here we kind of parted it as we went. The more we expose ourselves to this and work with this, we'll be able to go from square root of negative 25, well that's 5i. Or square root of negative 9, that's just 3i. But for our notes and to have a good resource, I want to kind of show you the in-between on how I'm arriving at this concept of I. Another example says this: express the square root of negative 24 in standard form. So this one you run your calculator and you now learned from page 1 that maybe you don't need to type in the negative, but you type in square root of 24. And square root of 24 is a decimal. If it had been 25, we could see that that's a perfect square. But this one we're going to have to do a little bit more work. You saw it earlier in the first unit, we did some breaking down of the square root of 24 other square roots by using a prime factor tree. So I'm going to come out here to the side and I'm going to break apart 24. You saw this when we were working with the quadratic formula, and we had to break apart what was under that square root if it was not a nice square root. So I'm going to say the square root of 24, I'm going to break it apart doing a prime factor tree. Contact me if you need some more resources with that. And I'm going to say what will multiply to give me 24? That would be a 4 and a 6. You could have picked 2 and 12 or 3 and 8. Any factors of 24 will get you to the same place. Break down the 4 into 2 and 2. Since 2 and 2 are both prime, I'm going to circle them both. Break down the 6 to give me 2 and 3. Again, they're both prime, so I circle them both. So instead of the square root of negative 24, I could say square root of, let's see, negative 1. And then instead of 24, I could say times 2, times 2, times 2, times 3. Since I have a pair of 2's, I could bring that out front to give me 2 square roots of, multiply what's left, 2 times 3, which is 6, and the square root of -1 is I. Now, typically, you're going to see that I written in front of the radical like that, because sometimes when you write in the back, especially if you're typing it into the online homework, you don't want to accidentally put it under the radical. You want to say you've removed it from the radical and it's outside. So you can place it behind it, but you're going to see it placed in front quite a bit, so it doesn't accidentally get under the radical. So with this, the prime factor tree is not new. The fact of having the negative and ending with the I, that was the new part. So we have the imaginary units. We have these things known as complex numbers now. So since we learned a new number system, let's figure out how these operations work on the new number system. So part 3, we're going to be looking at operations. We have things such as addition and subtraction. So the process is going to be, if I have the addition of 2 complex numbers, a plus bi or c plus di, I'm going to add the real part, and I'm going to add the imaginary part. Likewise, if I have subtracting, I am going to change all the signs. Now I'm just back to addition. A plus negative c gives me a minus c. B plus negative d gives me b minus d. So addition should go pretty straightforward. It's basically, if you consider like when we were adding polynomials, it's just a matter of combining like terms. So just a quick process to have in your notes. How to, given 2 complex numbers, find the sum or difference. Identify the real and imaginary parts. Add or subtract the reals. Add or subtract the imaginary parts. So let's do 2 examples. Let's do addition and subtraction. So I want to add 3 minus 4i and 2 plus 5i. So I'm just going to combine like terms. I'm going to add the 3 with the 2 to give me a 5. Negative 4i with the 5i to give me positive 1i, or just I. And again, this is just like if you were doing with x's. You would not change the exponent on the x into an x squared when you're combining like terms. So therefore, with negative 4i and positive 5i, you're just going to have an I, not an I squared. This would be my answer. Subtraction is where the details happen, or when most students make a small mistake. If you want to subtract 2 plus 5i from 3 minus 4i, most students don't really like to read in math class, and it gets you on something like this. Subtract 2 plus 5i from 3 minus 4i. That means 3 minus 4i is going to go in the front, minus 2 plus 5i. So if I'm going to subtract these, I am going to distribute that negative through the back one, changing all my signs. Now I'm back to addition. So I'm going to combine like terms. 3 and negative 2 give me 1. Negative 4i and negative 5i give me minus 9i. And that would be my answer. So subtraction is not bad. Just make sure you do distribute that negative through everything in the back, because most people mess up that back turn. And then stop here. This is not negative 8i. You don't condense it and smush it all together. You just want to combine like terms. And you'll notice when you're adding or subtracting complex numbers, your answer is a complex number in standard form, that a plus bi. Now multiplication, I'm going to go back to what we were talking about with working with x's. Multiplication says to multiply like a polynomial and use imaginary units as needed. So we might come in where we need an I squared equal to negative 1. We might need that eventually, so let's just put that out to the side. So I want to find the product of this. If this had been 4 times 2 plus 5x, you would have distributed it and been fine. The same is going to be true here with your imaginary. You're going to distribute. 4 times 2 is 8, plus 4 times 5i is 20i. And notice your answer is still a complex number. The next one, if you had been given, say, 4 plus 3x times 2 minus 5x, you would have distributed it, FOILed, Fox method. The same is true for your I. So you're going to multiply like a polynomial. So I'm going to distribute this out. This gives me 8 minus 20i plus 6i minus 15i squared. Combine like terms. This gives me 8 minus 14i minus 15i squared. And that's where you would stop with the polynomial. We know I squared is negative 1. Someone plug in I squared to be negative 1 right here. 8 minus 14i minus 15 times negative 1. Combine those two together. 8 minus 14i. Negative 15, negative 1 is positive 15. Combine like terms. 8 and 15 gives me a 23 minus 14i. So you'll notice these steps here, we're just spoiling, distributing, box method, whatever you can think of from your early algebra days. This is the only thing that we have added in, is changing this I squared to negative 1. Yet again, you'll notice, add, subtract, multiply, your answers all lift into a complex number. So make sure you remember I squared to negative 1 and you don't stop short from finishing out the problem. Now the last operation we need to do is division, but before we can talk about division, we need to talk about the idea of complex conjugates. A general note, the complex conjugates of a complex number, a plus bi, is a minus bi. It is found by changing the sign of the imaginary part and the complex number. The real part is left unchanged. So if I have some number a plus bi and I need to find its complex conjugate, you just change this middle sign to give you a minus bi. Likewise, if you start with a minus bi, again, you just change that sign there and that gives you a plus bi. Now, there's good problems on your homework and could be even on your unit exam of what is the complex conjugate. It could be as simple as I give you 9 plus 2i and say, what's the complex conjugate? So you just write 9 minus 2i. Notice the 9 did not change. It's not a matter of distributing a negative throughout. It's a matter of just changing the sign on the imaginary part. So if it says find the complex conjugate of each number, I'm only going to change the sign on the imaginary part, so it'd be 2 minus I square root of 5. Again, you'll notice they put the I in front of the radical so you don't accidentally have it underneath. This one only has the imaginary part, but the same is true. You only change the sign on the imaginary part. So negative 1/2 I, its complex conjugate would be positive 1/2 I. And it's as simple as that. I had one student say, is that all we do? That is all you do when asked to find the complex conjugate. So again, excuse me, good test question. So this brings us into division. How to. So to do a division problem, what we're going to do is we're going to write as a fraction, determine the complex conjugate of the denominator. Lots of good math words there. So the bottom number of our fraction, we're going to do our complex conjugate. Multiply the numerator and denominator of the fraction by the complex conjugate, and simplify. Better yet, let's look at an example. Notice it says, evaluate the expression negative 3 plus 4i over 2i and write the result in standard form. Nowhere did it say divide or multiply by a complex conjugate, so that's your part. You have to remember the process and the steps in order to work this. So if you're given this problem here, the first thing you're going to do is figure out where is your denominator. Here it is, it's that bottom number. Figure out the complex conjugate of 2i. Its complex conjugate would just be negative 2i. But if I want to multiply by negative 2i on the bottom, I also have to multiply by negative 2i on the top, because this creates a really special 1, something divided by itself is just 1, and multiplying by 1 does not change the value of the problem that I'm given. So when I go to multiply this, I'm just going to distribute like we did on a previous page. So it gives me positive 6i minus 8i squared all over. Multiply these two together, negative 4i squared. So just do your raw multiplication. Don't try to simplify, plug in for I squared or anything else. Now, once I've done what I can do there with multiplying, I'm going to plug in for I squared. So that gives me 6i minus, let's see, 6i, negative 8 and negative 1 is positive 8. Negative 4 and negative 1 gives me a positive 4. And then last step, divide both pieces by that 4. 6 over 4 reduces to 3 over 2i, and your calculator can help you with the reducing of that fraction. 8 over 4 is positive 2. So my final answer would be 2 plus 3/2 I. This is written in standard form, that a plus bi form. In order to get there, the main thing that we've learned here is multiply the top and bottom by the complex conjugate of the denominator. Let's do a little bit harder one, and you'll have an example of both of these in your homework. So I want to divide this. I want to divide 2 plus 5i by 4 minus I. So I'm going to multiply by a big old special 1. That special 1 is going to be the complex conjugate of the denominator, so that would be 4 plus I. If I do it on bottom, I also have to multiply it on top. So now I'm going to distribute this out. So 2 times 4 gives me 8. 2 times I gives me plus 2I. 5I times 4 gives me plus 20I. 5I times I gives me plus I squared. On the bottom, I'm going to distribute this out. This gives me 16 plus 4I minus 4I minus I squared. So that's just my raw multiplier. I did not plug anything in here. I'm going to combine like terms so I can put these two together. So it gives me 8 plus 22I plus I squared. All over these two would cancel. So 16 minus I squared. Now I'm ready to plug in I squared equal to negative 1. So I'm going to say 8 plus 22I plus negative 1 over 16 minus I squared, which is negative 1. Finish up my arithmetic. 8 and negative 1 give me 7 plus 22I. All over 16 minus negative 1, that gives me 17. Then to finish this out, I messed this up. So 5I times I is 5I squared. Excuse me. It should have been a 5. So times 5. And 5 and negative 5, 8. So it gives me a 3. I apologize. I missed that multiplier right there. So now to divide it out, we do 3 over 17 plus 22 over 17I. And the online homework will want you to enter this as the complex number in standard form. It will not accept this one. It does want you to go ahead and piece it out. So I hope this helps with your complex numbers. Just be careful. Be careful with your multiplication. You can see I made a slight mistake right there. Be careful with your negatives. Go slow. Show all your work. So in the test situation, I can give you as much partial as possible. Feel free to comment, to message me if you have any questions, comments, or concerns.